So now let's try this question. You have a medical imaging system. It sends a sound wave through bone that is 0.018 meters thick. If the speed of sound through bone is 2,100 meters per second, what is the time delay between the signal that is sent and the signal that is received? So go ahead and pause, try to solve this, and when you're ready, unpause. Alright, so let's write down what's given. You have 0.018 meters, so that's the distance x. And you have 2,100 meters per second, that's a velocity. And it says we're trying to find the time. So here, the picture looks like this. So you have the bone. And we're going to make some assumptions. We're going to assume that the imaging system is right next to the bone here. And what it's going to do is it's going to send a sound wave. The sound wave is going to travel across the bone at distance x, and it's going to travel back into the device over that same distance x here. So this is going to be a two-way trip. And as the sound travels through the bone, it's going to travel at the constant speed v. So in this case here, we're going to use the equation. Speed is going to be distance over time, but the distance is x one way and x back the other way. So it's 2 times x, or 2 times the thickness of the bone divided by t. And so here we can solve for t. I'm just going to do the algebra with the variables. So t is going to be 2 times x over v. So that's going to be 2 times the thickness of the bone, 0.018, and then divided by the velocity, which is going to be 2,100, and that's going to give you a time of about 1.7 times 10 to the minus 5 seconds, or I guess 17 microseconds. Okay, so next one. So this is a Doppler effect question. It says a jet engine has an on the ground vibrates at an audible frequency of 1,000 hertz. What is a frequency heard by an observer while the jet is in flight and approaching at 300 meters per second? So go ahead and pause, try to solve this, and when you're ready, unpause. So let's write down the givens. You have 1,000 hertz, which is a frequency, and you have 300 meters per second, which is a velocity. So there's not enough information here, so let's draw a picture. So you have a jet. There's a person on the ground, and you have a jet. When somebody in the jet, they're going to hear the jet whirring at a frequency. So this is going to be the frequency of the source, which is going to be the 1,000 hertz. So that's what you see when you're standing next to the jet. The jet is moving with the speed v, so that's going to be the velocity of the source. But now, the velocity of the source. But now, as the jet is moving, it's sending out sound waves, and those sound waves are traveling with the velocity of sound. I'll just call it velocity W for velocity wave. And because the jet is approaching the observer here, the sound waves are going to get compressed. So the frequency that the person hears is going to be, or the frequency that the person receives, it's going to be a different frequency. And we're trying to figure out what that frequency is. So the equation for Doppler effect is frequency received. Frequency received is equal to frequency of the source multiplied by this factor, which is going to be velocity of the wave divided by velocity of the wave, and then plus or minus velocity of the source. And specifically for this word problem, it says that it's approaching, and because of that, we're going to pick the minus sign. And from there we can plug in. There's also one more thing here, velocity of the wave. That's the velocity of sound. So here we're going to assume that the velocity of sound is going to be 343 meters per second. And so now we can plug in. The frequency received is going to be the frequency of the source, 1000, multiplied by this factor, which is going to be velocity of sound, 343, divided by velocity of sound, 343, minus the velocity of the jet, which is 300. And so the received frequency is going to be about 7,970 hertz. So it becomes high-pitched as the jet is approaching.